2,500 bar. I mean, what does that even mean? Let me put it this way. It's a level of pressure so incredibly high, it can slice right through your skin like a razor blade. That's the kind of force hiding inside a modern diesel common rail system, and learning how to respect it, well, that's what we're here for today.
To manage that kind of power safely, we're going to walk through 5 fundamental principles that you absolutely have to master before you even think about touching a diesel fuel injection system. And look, this isn't just theory. This is the stuff that separates a professional, safe job from a really, really bad day.
We're going to follow a pretty logical path here. First, we'll figure out what kind of system you're even looking at. Then, we'll get into high-pressure safety, how to keep contamination out, the power of a good visual check, and finally, how to wrap up the job and verify your work. All right, let's dive into our first principle, mechanical versus electronic systems. The subtitle really says it all. Know what you're working on before you touch a single tool. This is, without a doubt, the foundation for everything else we're going to talk about.
So what's the real difference here? You know, the older mechanical systems, they used a pump to physically push and control fuel through all these individual pipes. But electronic common rail, that's a whole different beast. It's all run by an ECU, and it uses a single, shared, high-pressure rail to feed a set of electronically controlled injectors.
Let's really zero in on that term, common rail. It's an electronic system that uses this shared or common fuel rail to basically store fuel at insane pressures, ready to go. And yep, there's that number again, pressures that can blow past 2,000 bar. This is what totally changed the game in modern diesels.
Now, why is this so critical? I think this quote from our source material just nails it. The procedures are, quote, fundamentally different. If you get the system wrong, you're going to grab the wrong tools, use the wrong safety measures, and follow the wrong steps. You're basically setting yourself up for failure right from the start.
And that leads us perfectly into our second principle, which is probably the most important part of this whole explainer: surviving high-pressure fuel. These aren't suggestions, these are the non-negotiable rules of the road.
I need you to really focus on this slide for a second. A spray of fuel from a leak so tiny you might not even see it can act like a hypodermic needle. It will inject diesel directly into your body. This is a massive medical emergency. The tiny hole in your skin might look like nothing, but the damage underneath is catastrophic and it requires immediate surgery. No exceptions.
So you're dealing with 3 main hazards here. First, that injection injury we just talked about. Second, stored fuel pressure. Just because the engine is off does not mean the system is safe. That common rail holds on to pressure like you wouldn't believe. And third, some of the newer systems use high-voltage piezoelectric injectors, which adds a very real electrical danger to the mix.
So how do we handle these risks? With a strict, repeatable process. Number 1, you have to follow the manufacturer's specific steps to safely depressurize that rail, every time. Number 2, only after you know that pressure is gone do you even think about disconnecting high-pressure lines. And 3, after the job is done, you have to properly prime and bleed the low-pressure side to get all the air out before you crank that engine over.
Okay, on to principle 3, keeping fuel contamination out. I want you to think of this like you're actively defending the system from its 2 worst enemies, because if they get in, they will wreak havoc on all those high-precision parts.
It really just comes down to this one simple question. With all this amazing, complex technology, what is it that actually kills a modern diesel fuel system?
Well, the answer really has 2 parts. First, microscopic particles, tiny bits of dirt or metal that act like liquid sandpaper, just eroding and scoring the insides of the pump and injectors. And second, water. Water contamination leads straight to rust and corrosion, and it can destroy expensive parts in a shockingly short amount of time. So how does the system defend itself? Well, the solution isn't just one single filter. It's a whole multi-layered defense strategy, and it's designed to stop these enemies long before they can do any damage. These defenses work together in a sequence. The first line of defense is the sedimenter, which is there specifically to separate out any water. The second is the primary filter, which catches the bigger chunks. And the final wall, the last line of defense, is the secondary filter. It's engineered to trap all those tiny, microscopic particles before they get anywhere near the expensive pump and injectors. This leads us right into principle number 4, the essential visual inspection. I love this subtitle, Finding Problems Before They Find You. It's all about being proactive, about the power of just using your eyes. So what are we actually looking for? This checklist gives you the big ones.
On the fuel lines, you're looking for any cracks, chafing, kinks, or any sign of fuel weeping out or actively leaking. On the sedimenter, you're looking for that telltale cloudy layer of water sitting at the bottom of the bowl. And for the air filter, check for blockages, damage, or a bad seal on the housing that could let dirty air sneak past.
And this is such a critical point. As this quote explains, you can have a leak so small that the diesel just evaporates before it even has a chance to drip. But that same tiny leak can be big enough to suck air into the fuel system, and that causes all sorts of headaches, like hard starting and rough running, the kind of problems that can send you down a diagnostic rabbit hole for hours, when a simple visual check could have found the issue in minutes.
And that brings us perfectly to our fifth and final principle, service and final verification. You gotta remember that job isn't over just because you put your tools away. You have to prove that you did it right.
The core service tasks here are really the fundamentals of a healthy system. You drain or replace the sedimenter, you put in new fuel filters, always making sure to follow the right bleeding procedure. And of course, you service the air filter and make sure that whole intake housing is clean and sealed up tight.
So let me ask you this. You've replaced the filters, you've bled the system perfectly, you've cleaned up your workspace, your tools are back in the box. Is the job finished? The answer is a loud and clear no, not yet. And here is exactly why. A connection that feels perfectly tight when you're just priming the system at low pressure might start to seep or weep once the engine's running and it's under full operating pressure. The only way to be 100% sure your work is correct and safe is to start that engine, let the pressure build, and do one final thorough visual inspection for leaks. That final verification, that's what actually finishes the job. So, we've covered it all: identification, safety, contamination, inspection, and verification. My final question for you is this. Now that you're armed with these 5 principles, what's the very first thing you're going to check or just think about on your next diesel job? Thanks for joining us.